Comets are icy, rock and dust planetary objects, forming in our sun's neighborhood's far reaches. Comets can be distinguished from asteroids by their lack of a solid nucleus. These ice relics, from the initial periods of our universe, can be propelled in the direction of the solar system's interior by gravitational disturbances caused by other heavenly objects or other foreign sources. If a comet had to collide with Earth, the occurrence would have massive implications, the exact nature of which would be determined by a number of variables such as the shape, velocity, and makeup of the comet, along with the destination of the effect and how the atmosphere of Earth would react to it. Stay with us till the end of the video. There's a lot of information to be revealed. The magnitude of the hit would be strongly influenced by the comet's size as well as its velocity when it made contact with the planet. Comets can range from only a few meters to many kilometers in diameter, depending on their specific composition. On collision, lighter comets, the kind that usually have a diameter of less than 1 kilometer, are more likely to produce a relatively modest crater and cause severe damage that is more limited. The kinetic energy produced during the collision would lead to the incision of the targeted region, generating a hole that could be anywhere from a few hundred meters to several kilometers in size. The diameter of the crater will be determined by the dimensions and pace of the comet, in addition to the structure of the location where the hit took place. The immediate area surrounding the point where the impact occurred would be the primary target of any localized destruction done by a comet strike. The crash would cause a massive quantity of energy to be released, which would eventually impact blast waves, warmth, and wreckage being launched into the air. The heat that is produced by the collision has the potential to start fires, and the blast wave that is emitted has the possibility of causing structural failure to the buildings and other facilities that are located in the surrounding region. Debris hurled from the point of contact may also create secondary harm in the areas that are close. The repercussions would be even more catastrophic if a giant comet with a diameter between 1 and 10 kilometers had to make a big impact. If a comet collides with an open sea, it has the potential to set off storm surges, which are enormous waves that are created when water is displaced as a result of the collision. It would cause a significant amount of energy to be unleashed, which would cause a great amount of water to be displaced. It would create enormous waves, which may spread throughout the oceans and cause massive damage throughout coastal locations. The volume and scope of the storm surges would be determined, in part, by the comet's dimensions and velocity, as well as by the water depth at the point where it hit the sea. The material and dust that would be ejected into the atmosphere as the outcome on the Earth's surface constitutes one of the most severe potential outcomes. Large amounts of dust, stone pieces, and gases would be released into the environment and dispersed across the globe. Due to the presence of dust and other junk in the environment, the quantity of sunlight that reaches the Earth's outermost layer will be diminished. This would cause a decrease in temperature, which might possibly lead to modifications to the environment in the near term. The less sunlight that is available will also have a negative effect on photosynthesis, the biological mechanism through which plants use sunlight to make food. This might have huge repercussions for farming and the supply of nourishment. There is a risk of food scarcity as a result of damage to sunlight-dependent crops and plants, which could contribute to a deficit in the food supply. In this case, if a highly giant comet, one with a diameter of more than 10 kilometers, were to collide with Earth, the results could be disastrous on a world basis. Because of the enormous quantity of energy that would be unleashed as a consequence of the collision, there would be widespread damage and calamity. The particles of dirt and other objects launched into the environment would obscure the sun's rays, leading to extended nighttime and lower degrees. This could have a tremendous negative influence on the climate of the entire planet, leading to what is known as a nuclear winter. During this time, levels would plummet, and the amount of sunlight would be severely diminished for a number of months or perhaps centuries. This might result in nationwide poor harvests, the upheaval of habitats, and even the possibility of massive extinctions, as many creatures would need help adapting to such abrupt shifts. The repercussions of a comet strike would provide difficulties in terms of the reaction and recuperation operations that are undertaken. It is highly possible that the obvious impact might cause tremendous devastation of structures, including houses, highways, and telecommunication systems. This would pose a challenge for emergency responders and rescue crews to reach places that were affected. The diversion of the water and food supply could result in humanitarian catastrophes. The absence of power and other necessities could further worsen things and make them more difficult to manage. Moreover, the debris and dust that would be emitted into the environment would be hazardous to the health of both individuals and animals. Inhaling the fine dirt and debris particles could lead to breathing difficulties, and the poisoning of water supplies could further worsen the situation, possibly leading to a more serious public health crisis. The ecological impact over the long term must also be evaluated, since the particles and pollutants might conceivably have an effect on habitats, water management, and nutrient retention, which could have far-reaching implications for the Earth's natural diversity and general well-being. This would require analysis. The influence that comets, which are archaic relics from the initial solar system, had on the planet's past can be deduced from the many geological and meteorological archives that have been kept. The Cretaceous-Paleogene environmental catastrophe, which took place around 66 million years ago, is a famous illustration of this phenomenon. A collision with a comet or an asteroid is considered to have been the primary origin of this event, which is likely to have ended in the global catastrophe of several creatures, along with the dinosaurs. The hit crater, renowned as the Chicxulub crater, which can be found in what is now the Mexican state of Michoacán, has been pinpointed as the likely impact location connected with the KPG extinction event. A further illustration of this is the Tunguska event, which took place in 1908 across a desolate region of Siberia in Russia. This occurrence is thought to have been brought about by the collision of a minor comet or asteroid, with a size ranging between 50 and 100 meters. The collision caused a massive explosion, which was comparable to several megatons of TNT, and it brought down an estimated 80 million trees across an area of 2,000 square kilometers. Fortunately, because of the event's remote location, there were no reported civilian casualties. Nonetheless, the effect did have severe consequences on the environment and the structures in the area. There is a probability that a comet might collide with Earth at some time in the future. Even while the possibility of a comet hitting Earth is quite minimal, it is not utterly impossible for such a catastrophe to occur. The comet's routes in the planetary system are susceptible to alteration due to a number of variables, one of which is the gravitational force exerted by other heavenly bodies. Comets are moving all the time through the universe. Because of this, a comet's path might shift throughout its lifetime, and it can be challenging to determine with absolute confidence whether or not a specific comet will collide with Earth. There are presently available comets whose orbits bring them within relative proximity to the Earth's orbit. Nevertheless, it is not anticipated that these comets' paths will culminate in collisions in the near term. On the other hand, new comets can be found at any moment, and their orbits could put the Earth in danger of being struck by one of them. In addition, minor comets or comet bits, which are collectively referred to as meteoroids, are able to penetrate the environment of Earth and have the ability to cause damage to the planet. Researchers and space organizations are making attempts to find and analyze comets and other NEOs that could constitute a possible impact risk. These NEOs include asteroids and comets. The detection and tracking of comets' motions, as well as the calculation of their paths, are conducted through the employing of observational tools, such as telescopes and other equipment. If it is discovered that a comet is heading toward Earth on a crash trajectory, Additional observations and computations will be carried out to evaluate the threat and possible effects. If a comet represents a realistic threat of collision with Earth, there are potential actions that could be done to reduce the severity of the risk. Altering the comet's path and preventing a collision with Earth can be accomplished by a variety of methods, some of which include the deployment of spacecraft to redirect its route, the utilization of gravitational aids from other celestial objects, and other strategies. It is essential to be aware of the fact that the likelihood of a comet colliding with Earth during any certain time period is relatively low. On the other hand, as was stated before, the possible ramifications of such an event would be tremendous. They might have far-reaching implications for the climate of the entire world and the ecological systems and human communities on the planet. Thus, continuous monitoring and analysis of comets and other NEOs, as well as preparation and mitigation activities, are necessary to preserve the security and well-being of our planet. Thank you for watching. If you have any questions, let us know in the comments section. Also, at last, give a like to this video. See you soon.